Okay, guys. Good morning, everyone. So it's first recitation class, section 202. Right now there are 14 of us. Right. Again, as I said, now you cannot mute me, but I hope you can hear me well. Right. Again, if something happens suddenly, right, hiccups happens. Right. So just tell me. The speaker is on. Okay. So. In the lecture, right, we didn't introduce much in terms of fundamental stuff, right? It was just an easy introduction lecture. What we need from the lecture today only Coulomb's law, which is what? Which is a law, universal law, right? Which describes interactions between point charges. It can be used only if you have point charges, right? And then. But what if you have more than two charges? Principle of superposition. So basically, these two things we need in today's class: Coulomb's law and principle of superposition. That's it, right? And so let's look at the example. It's a chapter 22 and problem 43. Very similar problem will be in your homework. All right. So let me write. So it's 2243. Chapter 22, problem 43. Right, and we have three charges. Some of them positive, some of them negative, right, at a certain distances, and we will need to find a net force on one of those charges. Basically, the idea of this problem, practice Coulomb's law, but Coulomb's law, it's not a big deal to practice, right? The basic idea of this problem is to refresh vector algebra. Right, because we are going to deal with vectors pretty much the whole semester, except for a couple of weeks of semester. And every day, not every day, every time we will have to deal with vectors. So it must be really fresh. And I know students struggle with vector algebra. Okay, so now let me draw the situation. As I said, three charges. Okay, I will grab my notes so that I can see better. Okay, so the first charge is over here at the origin. It's a positive charge, plus. Then negative charge will be on the x-axis. Okay, I will label x's in a second. I'm trying to estimate the amount of space I might need. So here will be negative charge, minus. Right? And just above this charge, there will be another positive charge. Right. So there will be a positive charge plus. Okay, now I need to label them. Right. So this is the first one, Q1, 5 nanocoulombs. Maybe I will write it over here. So Q1 is 5 nanocoulombs. Right. Then this will be 2. Again, guys, at any moment, if something is not clear in terms of my handwriting, right, because students complain that it's difficult to tell the difference between my N and the letter U, right, and or something not clear in terms of explanations, just as I told you in the lecture, I will be happy to hear people's voices. So then, Q2 is minus 5 nanocoulombs. And this Q3 is 10. Okay, so that's the electrical configuration, electrical part of the system. Now a little bit of geometry. I still haven't labeled axes, damn it. So x and y, of course, right? Then some geometry, and geometry is this. So let me draw this auxiliary line, and this distance is b 3 centimeters, and this distance, from the origin to this point, a is 4. Right? Okay, so that's the problem. I mean, that's the situation. And the question is, we need to find the net force acting on this charge Q1 at the origin. So now let me write. So we need to find F. Okay, let me label it as F1. Basically, it's on Q1. The net force acting on the charge Q1. Right. Okay. Okay, before we started getting into the details, we need to discuss it, right? Basically discuss the strategy. And usually I prefer, and I force students to do that, right? Especially graduate students when the situations are significantly more complicated in classical mechanics. I prefer to draw a nice picture because it reduces chances of making a mistake, right? Because you can see the picture better. I mean, the picture of the situation, right? So here, let's do the same. And what we need here in order to continue solving the problem, we need to draw all the forces, right? And only after that, I will start discussing the the strategy of the problem. Okay, so usually I ask students to give me these forces, right? But now, let me do this. All right, so of course, Q2 will act on Q1, force of attraction. Right, force of attraction, so this charge will experience force that way, right? Because they're opposite. So let me draw it. So this will be force. Let me label it F. Since it is the force between 1 and 2, I will label it F1, 2. So the first force, right? Then, of course, this guy is going to push this guy, because they are like charges. Of course, there will be force along the line connecting them, but away. So this will be the second force. F, now it's 1, 3, because this is the force between charge Q1 and Q3. So it makes sense to label it 1, 3. All right? And then we need to find the net force. So we just need to add them. Now at this point, it's a principle of superposition. We need to add them up as vectors, right? So let me draw this parallelogram, right? Okay, it's slightly distorted, but good enough. All right, so we need to find this force. That's our force F1, which needs to be found. Right. Okay, now picture is here. So now we can discuss pretty much everything that we need is on the diagram. So now we need to discuss the strategy. Right? Again, before we start crunching numbers, we need to make a decision like a generals before battle, right? So we're going this way, and then soldiers will bleed executing those decisions, right? Okay, so the strategy will be this. So can we find the absolute value of this force F12? Piece of cake, direct application of the Coulomb's law, right? We know charges, we can find distance, so we can find absolute value of F12. Then, can we find components? X component of that force and Y component. The force is purely in the X direction. It's a piece of cake again, right? So we can find components of the first force. Can we do the same with F13? Again, first the magnitude. Again, magnitude is the strength of the force, right? Then, if we find one of those angles, we should be able to find components of this force. And then we will have two vectors with components. How can we add two vectors if components are given? Again, for you at this point, it should be very simple. We just need to add corresponding components. That's it. And that will be the components of the net force. So that's the approach I'm trying to take. Find components of this vector, components of that vector, and add them up. And then we will find the magnitude, the direction of the net vector, because that's what mastering physics asks you, because very similar problem will be in your homework, right? Okay, clear? If no objections, let's just start now crunching numbers, right? And again, the whole point is just to refresh vector algebra. Right, so let's start with F12 because it's easier. All right, it's the easiest one. All right, so you know what? Okay, yeah, I have enough space. F12. I've developed a habit of trying to save the space on the whiteboard since it's small. So F12, and again, it's right now it's not a vector; it's an absolute value of that vector. It's a magnitude. So that constant k, then absolute value of q1, you see absolute value, because I'm just trying to find the magnitude. And then since we have a nice diagram, I can take care of the directions as if we need that. Then multiply by the absolute value of the charge q2, right? And divided by the distance between these two charges. R1, 2, it's a distance between the charge 1 and charge 2. And of course, we know what this distance, it's just b, right? R1, 2 is b. Right. Okay, since you weren't with me in Physics 1 and you're not familiar with my notations, what I like to do, at some points, I usually like to open what I call explanation box, where I write what I'm trying to use in order to move from this point to the next point in the line of calculations, right? So for example, in this case, I want to show that R12 is just B. Right? I'm just explaining what I'm going to use here. And of course, B is 3 centimeters, but of course, we have to convert it to meters. Don't forget, because I see some students still make these mistakes, silly mistakes, of course. All right, so it will be 3 times 10 to the power of minus 2 meters. So that's what I'm planning to use, right? And so then you can plug numbers. I'm not going to do it, right? In my first semester, I remember I tried to plug numbers, and then in the evaluations, one student wrote down, okay, don't plug numbers, we can do that, right? So I just usually write down the answer, right? All right, so charges are given, distance is given, k, universal constant. If you plug all the numbers, you will end up, and don't forget, okay, let me emphasize, nano, 10 to the power of minus 9. Right. Sometimes students forget, not many, but still it happens. Okay, let me emphasize. So this is 10 times 10 to the power of minus 9 coulombs. Coulomb units of charge. Right. Okay, so if you plug numbers, you will end up with 2.5 times 10 to the power of minus 4. And that is just a force. Electric force, but just a force, units of Newton. Okay, so that's the absolute value. So you remember now the next step. Components, we need to find components of this vector. And in this case, it's trivial because the whole force in the x direction, so a y component will be 0. And the x component will have this length, right? Okay, so now we can write F12 sub x, right? It will be that. 2.5 times 10 to the power of minus 4 newtons. And F12 sub y, it's 0. Okay, that's the first step. You remember in the strategy, we found components. Let me frame it so that I would be able to find it easily. Right. Okay, and it's not red because it's a preliminary result, not the final result. Okay, now let's try to do the same with F13, but of course now it's complicated because the vector is at some angle, which we still don't know. All right, so now let's do the same with F13. Okay, I put a new bullet here. So now it's F13. Again, I want to find magnitude of that vector. So I will put, again, absolute values, right? Because just magnitude can be only positive, right? Again, so it will be F13, K, absolute value of Q1, absolute value of Q3, because it's between these two charges, and divided by the distance R13 squared. Where is that R13? Between charges, 1 and 3. So this is our R13, sub 13. Right? Okay, can we find this? I'm sure that you can see that it's you can use this right triangle or that right triangle, Pythagorean theorem, right? So piece of cake. Again, I will open my explanation box to take care of this distance R13. When I was an undergrad student, my professors used that and I liked it, and I still like it. So R13 equals square root of this distance is a, this distance is b, this side is b. So square root of a squared plus b squared. A squared plus b squared. So it will be 5 centimeters, or of course you have to convert to meters, right? So it will be 5 times 10 to the power of minus 2 meters. Right. Okay, so now, again, charges are given, k is known. All right, we can calculate the, and the answer will be, of course, I don't remember, let me look at my notes. 1.8 times 10 to the power of minus 4. Again, newtons. Okay, I tried to squeeze it, right, so that I wouldn't have to open, so I don't have to open a new line. 1.8 times 10 to the power negative 4, minus 4 newtons. Okay, and now the next step, of course, again, the same, we need to find components, but now it's not as trivial as here, right? So in order to find components, of course, we need to find either this angle or that angle. Which angle to use, it's up to you, right? But of course, since it's my solution, right, I will pick the angle, right? I think I will pick this angle between the vertical line and the vector. Right, so let me use blue. I think, yeah, that's the angle I use. So, and let me call it theta. Right. Okay, can we find that angle? If we look at the geometry, what can you say about this angle and that angle? This and that. They're the same, right? They're vertical. Because they're vertical, basically by the geometry we can say this is also theta. And of course now, if we are over here, look at this triangle, it's the right triangle, we can easily find the angle. But be careful, because again, I notice it's simple things, but lots of students struggle with usage of sine and cosine function, right? But in this case, I would probably use tangent. Tangent of this angle, it's a opposite side versus adjacent side. You remember properties of the right triangles, right? We're going to use them a lot, right? And very often I see very silly mistakes on the exams, on tests, right? Just students making mistakes with the sine, cosine, or tangent functions. Right, okay, so this triangle, tangent of theta, it's a b over a, right? Again, if you don't see it, tell me, right? Right, so tangent of theta, it's a opposite side versus adjacent, so it's a b over a, right? B is given, a is given, so take arctangent, and of course you will get the angle theta. Theta will be arctangent of 3 over 4. It doesn't matter if you use meters or centimeters because it's a ratio. And you will end up, okay, 36 point, okay, I use more sig figs, 36.87 degrees. Okay, and after this point, now, yeah, we're ready to find components. You know what, I'm not going to write here because it's difficult here. There is a surface. I will just move over here. So now let's find x component, okay, of this vector. Again, I will draw these auxiliary lines, right? So this will be, of course, x component, right? You see this, let's find this component. Right, so f(1,3) sub x, okay, blending, right, f(1,3x). Okay, which function do we have to use in order to find this side? Sine or cosine? Again, here, plenty of mistakes, right? Strong students, of course, surprised, right? But lots of mistakes at this point, right? So we need to find, you see this rectangle, we need to find this side, or basically it's that side as well. This side is opposite to the angle which I decided to use. So of course, in order to find the opposite side, we need to use sine function, right? Cosine function is used to find adjacent side. Opposite side, can be found using sine function. So, of course, here we need to use sine function. Now let me write it. So it will be F13, it's a hypotenuse, times sine of angle theta. Okay, now I will pause and I'm not going to move until I hear your voices and opinions, right? Because it's very important. Are you happy with this? Now I'm asking about your happiness, right? It's not going to happen that often. But are you happy with what I wrote or not? Or what can be changed in order to make you happy? It's one of the crucial part of the solution where students can easily make mistakes. What? Or maybe it's absolutely correct, right?
Everything to me looks fine. My only, I think a little bit of confusion was just where you wrote F12, like the whole equation, like K absolute value of Q1, Q2, and you just went straight to the, like you went straight to the answer. Because I was also
Because,
doing the homework yesterday.
Okay, got it. Because we know everything. K is a universal constant. It's 8.9910 times 10 to the power of 9. Universal
Yeah.
constant, that K. You can open the book, right, and you can see that.
Yeah.
It's a Coulomb's law. Then charge Q1 is given, right?
Q1's given, Q2's
Q2
given.
is also given. So I just plug all the numbers and calculate it, right? And of course, distance here, R12, it's a 3 times 10 to the power of minus 2 meters, right? I just plug numbers and calculate it using calculator.
Yeah, I see what I did wrong yesterday, because yesterday I was thinking everything still had to be multiplied by power of 10. I see what I did wrong.
Okay, you jump ahead and solve the problem before.
Yeah.
Okay, it happens. Okay, good. But back to this.
It's not supposed to be F13 divided by sine of theta?
No, not divided by sine, multiplied, because hypotenuse is longer. Adjacent side or opposite side, they're smaller, and cosine and sine function are smaller than 1. You have to multiply in order to get the smaller number. So it's a multiplication now. Right? I do it every time, right? At this point, I stop and I torture students, right, for a few minutes, right? Because not everyone sees this subtle moment, and it's a very important moment. Okay, can anyone tell me what is, okay, maybe not wrong or maybe completely right? Okay, don't be surprised. It happens every semester, right? So that's why I push on you so much here. Now let's look at the direction of this component. You see this vector F13 points that way, partially in the negative x direction. So what can you tell about the component, x component of this vector? On purpose, I didn't show a direction. The component must be negative. This component must be negative. And students miss that point. That's why I stop and torture you so that to create like some disturbances in your brains, right? Yeah, this is minus. We have to put minus. And of course, and since we don't use the conventional angle, right? You remember the conventional angle. If you, for example, have here the coordinate system, right? And let's say this is your vector, right? Conventional angle is this, right? In order to find, and if you use this angle, right, in order to find components, and if you use this angle, that minus will pop up automatically from the value of sine function. But since we don't use conventional angle from the positive x direction measured, since we measure the angle you see from the negative y direction, it's a not conventional angle in vector algebra. So we have to take care of the pluses and minuses manually. That's why we need picture, right? So over here, manually, we have to put minus, right? Because again, in vector algebra, you remember, in order to find proper angle, proper sides, you need to use the angle from the positive x direction counterclockwise, conventional way of measuring angle. It's one of these subtle points over here, right, which, yeah, I have to. Okay, I will use red in order to emphasize on that. So minus manually, that minus will never pop up automatically. Okay, so now, of course, you can plug F13 is given, oh no, found, we found it. The angle we found, you can plug it. Negative, okay, I use more sig figs, all right, and then at the end, usually it's better to round it off, right, minus 4 newtons, 1.08 10 to the power of minus 4, negative 4. Right. Okay, let's find the y component. F13 y. Okay, so y component, of course, it's this, right? That side. Of course, it's adjacent to the angle which we decided to, I decided to use. And in order to find adjacent side, of course, we need to use cosine function. Again, F13 times now cosine theta. And again, what about the sine? Now, yeah, you should be able to see it now, right? So now, again, we need to put manually minus, because this component is down. All right, so again, we need to put minus manually, because again, the angle is not conventional, unconventional, so we have to take care of the pluses and minuses manually. Right. So, and this component is going to be minus 1.44 times 10 to the power of minus 4 newtons, right? Okay, so now we found components of the second vector, right? So I hear you. You remember I framed in blue. So now the second blue box. And now the final part, if you have two vectors represented, given in the component form, so we just need to add corresponding components in order to find the net vector, components of the net vector. So now principle of superposition, right? So of course in the vector form it will be just F12 plus F13, right? But in components we just add x components and add y components separately. Right, so which one I did first, it doesn't matter. Okay, yeah, let's do it. Logically, let's find x. F sub 1x, x component of vector F1. So we just need to find, okay, x component, right? So it will be 2.5 minus 1.08 times 10 to the power of minus 4 newtons. So it's this component minus that. That is positive, that is negative. Right? And that will be, of course, 1.42. Yeah. 1.42 times 10 to the power of minus 4 newtons. So that is the x component of this vector F1. Our desired vector. Now let's do the y component. Y component is trivial because this is the 0. Right? So pretty much the whole component comes from this. So it will be F1y. It will be just minus, okay, probably let me write it first. And I should have done the same over there. So it will be F12 y plus F13y. So just adding components, right? I just realized that I should have written over here the same, right? Right. So of course it will be negative 1.44 times 10 to the power of minus 4 newtons, right? And let me remind you that this component F12y, it's just a 0. Yeah. Okay, so basically at this point we can say problem is solved. we have components of the vector which we wanted to find. What else do you want? But Mastering Physics in the book asks, find the absolute value of vector f1 and find its direction. Just logical question, right? So you want to know more about this vector f1. Absolute value. Okay, quite often here students, because now we have so many vectors, so many different angles, right? So now if I start adding additional vectors, sometimes students start getting confused, right? Although when I draw a separate picture, everything gets fine. All right, let me redraw that picture again. So this is our y, this is our x component, right? I mean x-axis, and our vector f1, it's over here, right? So that's our vector f1. All right. And what we just found, these components, so this. So this is f1x, and if I draw line and draw it here, it will be f1y. That's what we found. This is f1x, and this is f1y. So now if the question about find the find the direction, again, it's a rectangle. So in order to find hypotenuse, right, basically magnitude is the hypotenuse, right? It's this square of this plus square of that, and take a square root, right? But very often, if I don't draw this picture, many students get confused at this point because of the picture getting kind of more and more complicated. So it's better to draw a separate one. Right? Again, if this is not clear, tell me. But I noticed that, and that's why I started drawing the additional picture. Right, so f1, again, it's just the magnitude of the vector which we found. It will be f1x squared plus f1y squared. No, just Pythagorean theorem. And of course, the answer, I don't remember. Let me look. It will be 2 times 10 to the power of minus 4. 2 times 10 to the power of negative 4. And again, it's just a force, magnitude of the force, newtons. So it's a magnitude. Okay, let me maybe write on top. It's a magnitude. And now let's find direction. We just found magnitude, and now let's find a direction. Direction, again, Mastering Physics and the book asks relative to the positive x-axis. So basically, they ask to find this angle. Okay, let me label it over here. This angle phi. Let me introduce angle phi, right? Because again, the book asks, and the Mastering Physics in your case will ask you, find a direction of vector f1 relative to the positive x-axis. Okay? And again, if I don't draw that picture and just ask students over by looking at this picture, I don't know, 40% of students usually get confused. Okay, just roughly 40%, right? But once you draw the separate picture, right, so now it's simplified and you know how to deal with the single vector, right? It's quite straightforward, right? So now you can use anything. Most likely I will use, okay, this triangle, and I use tangent of phi. Or you can use sine, cosine, because now we have everything about this. We know everything about vector f1. Right, so tangent phi, it will be opposite versus adjacent, right? So this is, again, it's a f1y, this side, right? This side, f1y, it's the same as this one, right? Because it's a rectangle. And this side, and that side we have already. And right now it's just a geometry, right? We just need to know this length and that length. So if we have any pluses and minuses in our components, drop them. Because now we're just looking at the triangle. So it will be absolute value f of f1 opposite y. If f1y, it's opposite side. All right, it's this triangle again, I'm emphasizing. This point, this point, this point. So that triangle. And versus the absolute value of f1x right? Okay. One 1.42, 1.44, take a ratio, it's 1. So the angle is going to be approximately 45, very, very close to 45 degrees, right? Phi is going to be very close to 45 degrees, right? Okay, so now, another thing. If I leave my answer like this, would it be good? Here we have to be careful, right, with these angles, because this is a not conventional angle. You remember again, conventional angle we discussed is measured from the positive x-axis in a counterclockwise direction. We're not using conventional angle. So we need to add additional words, because if I leave the answer like this, and if somebody looks at the angle, this, which describes the direction of the vector, that person would assume that the vector is in the first quarter, but it's not. So we need to add additional words. For example, we can write below plus x-axis, or this is clockwise from plus x-axis. I think mastering physics will ask you in terms of clockwise, counterclockwise. So we need to add additional words. Otherwise, it would be confusing for people who would read your solution or your report, right? So we need to remove all the ambiguities, and so I will add. So it's a CW from plus x. Counterclockwise direction from plus x direction. Or we can write minus 45 degrees. Yeah, that will be clearer, right? I will write or phi equals to minus 45 degrees. In this case, we don't have to add anything else. Or we can write below plus x-axis. Or we can even introduce conventional angle, right? Or we can write that we can use this angle, right? Conventional angle from positive x direction. In that case, again, we wouldn't have to write anything else. So in that case, it will be 360 minus 45. It will be 315, right? 315 degrees. I think so, yeah. Or 315 degrees, right? Conventional angle. But again, in your homework, look carefully next to the box where you have to enter the answer in mastering physics. I think it usually shows CW or CCW, right? So use that notation, because mastering physics is just a piece of programming, right? It doesn't understand the logic, right? Okay, so again, the point of the problem, just to refresh vector algebra, because we're going to use it almost every class, finding components, directions, magnitudes, right? So it will be, yeah, throughout the whole semester. So that's why we spent almost, lots of time discussing this. Okay, if something not clear, tell me. And now let's discuss another problem, right? Because there will be very similar in your homework. Where's my eraser? Ah, here it is. Okay, I will start erasing this. If you're not screaming about something which is not clear. And yeah, I will erase all the way to. Now the problem is about finding the charge. Finding the charge can be complicated, right? Because you need to have some special devices. It's not like measuring distance or mass. Devices usually are trivial, which can be used to measure that. But measuring charge is more complicated. But we can easily set up this situation. We can take, for example, one ball which is charged. Take another one, exactly the same, touch them, and of course they're going to have exactly the same amount of charge. right? Equally charged. Then you can attach strings, attach it to the ceiling, and of course release them. Of course they're going to repel each other, and they're going to position like at a certain angle. They're going to stay at a certain angle, so that they will reach static equilibrium. And using that situation, we should be able to find the charge. It's a problem 43. Yeah? Yeah, it's, no, 73, sorry, 73. Okay, I will start with the picture. So that's ceiling. Then we have these two charges. One is here. The other one, of course, will be symmetrically positioned over here, right? So this is mq, and this has mass and charge q. Q will have to find, mass is given. Okay, let me write. So m equals to 3 grams. Charge, we don't know. And of course, when you set up this experiment in order to calculate the charge, you can measure what else? You can measure this length. L is 1 meter. L equals 1 meter. Then you should be able easily find this angle theta. I think it's at 20 degrees, if my memory is not failing me. Yeah, 20 degrees. And I feel like something else is given. Nope, that's it. So we need to find charge. Let me move this cat over there. Find Q, charge. Right? Yeah. So, what can be done? To start, again, first we need to make a decision like a general. What are we going to use and which direction we're going to go? Again, usually I have 4 students at this point, but let me guide you immediately because we're getting closer to the end, right? Which law can be used to describe any motion of any system, classical system in the universe? Since you were not with me in Physics 1, right, so you might be confused about this question, right? So which law can be used to find motion of any system? It doesn't matter. Motion of the car, motion of the cat, motion of the galaxies somewhere, motion of binary stars, right? It doesn't matter what. You should be able to grab that law and use it to describe the motion. And everyone knows that. You all know that. I can bet all my, oh, probably I shouldn't be betting my money right on that, right? All right, but I'm sure that most of you know that. Which law? Newton's second law. That's what Newton's second law is. It's an equation, it's a law which is capable of describing motion of any system. It doesn't matter, just grab it and use it. It can be painful, right? But theoretically it should be possible. So if we, okay, let me write. So probably I will write right here. Any motion can be described, described by, okay, let me write it. Sum of the forces acting on the object of mass m leads to acceleration. Newton's second law. Now, let's adjust to our case. In our case, do we have any motion? Of course not. Can this be used to describe a system which doesn't move? Why not? No motion, it's a special case of a motion, right? No motion, it's a special situation of a motion. So how can we adjust this in order to apply for our static situation? We have static equilibrium. You just put acceleration to 0. In our case, acceleration equals 0. And as a result, we will get the equation which we need to start solving this problem. Okay. let me write it, in our case of no motion, acceleration is 0. So as a result, the starting equation which we need to discuss is net force acting on the system equals 0. Effectively, it's barely a Physics 2 problem. It's a Physics 1. At the end of the Physics 1 semester, right, you discuss static equilibrium situations, like there's beams or ladders against the wall, right, all that stuff. It's exactly the same. It's just one of the forces is an electrical force. Otherwise, it's basically a Physics 1 problem. So that's the beginning of the solution. Net force, we just need to balance all the forces. And of course, in our case, right, so since the situation is two-dimensional, we have vertical direction, we have horizontal direction. Of course, inside of this equation, we have two equations, x component, y component. Right. So now we see that we need to analyze all the forces acting on the system. Of course, we will just look at one of this on this object, for example, on one of this, right? M. I pick this one, and I will introduce coordinate system. So now without coordinate system is impossible. So this will be y, this will be my x, right? And now we need to draw all the forces. Basically, now we are completing free body diagram. I introduce coordinate system, and now we need to show all the forces. Right, so the first force, of course, ubiquitous, right? Students like it. The students usually mention that force first one, right? Whenever I ask, gravity. So, okay, mg. Then the next one, okay, I'm moving a little bit, answering your questions. I usually ask that students all the time in normal classes. Then, of course, there will be tension along the chord, right? Along the chord, away from the object. Which way I label it? T or ft? F sub t. Okay, not a big deal. F sub t. Right. And then what else? These two charges are identical, like charges, right? This and that, so of course they're going to repel. So the electric force, of course, must be this way. So let me label it as F sub E. That's it. No more forces after that. So we just need to find components. Of course, let me first write down in a vector form, right? So now I'm just writing explicitly this formula, right? So it will be F electrical plus mg plus ft equals to 0. So I just wrote down explicitly this formula. And now, again, we need to write this for in terms of x components and then y components. So we're going to end up with two equations. Right. Okay, so now, which one I wrote first? Okay, let me start with the y. Sum of the forces in the y direction, or sum of the y components of the forces, sum of the y components of the forces must be equal to 0. Just expanding this, writing explicitly. Right, okay, now we have to carefully take care of the components in the y direction. Ft, y component, it's this component, right? And you see, it's like in the previous case, you see this. But now y component is in the positive y direction, so that component is positive. So that ft goes into the equation with plus. So it will be plus ft, and which angle? This is theta, right? This angle and that angle by geometry the same. So ft times cosine of angle theta. Right? Electric force, purely in the x direction, so no contribution, and mg purely in the y direction, negative y direction. So it's a minus mg equals to 0. So that is equation number 1. Equation number 1. Right? So now let's do the same with the x components. Sum of the x components must be equal to 0. So x components, electric force purely in the x direction, positive x direction. So contribution is positive. So plus F electrical. Now, x component of the tension. Again, I will just draw this dashed line. And this component, you see, it's in the negative x direction, like what we discussed here. Component in the negative x direction. So it must go into the equation with minus. Right? So it will be minus Ft. And this is a sign. We have to use sign because this is, again, angle theta in order to find the opposite side. Opposite to the chosen angle, given angle, not chosen, given. Ft sine theta equals to 0 because mg doesn't contribute anything. Mg is in the y direction. Equals 0, so equation number 2. Basically now 2 equations, now we need to count unknowns, but look, inside of the electric force still plenty of stuff. We need to reveal that stuff from the F electric. And we have 2-point charges, so we can use Coulomb's law to find F electric, right? Okay, now let me write that F electric, and the rest, how to solve the system, you will be, I'm running out of time slightly. Okay, just one more minute. Let me write F electric. And then, so of course it's a Coulomb's law, K, Q times Q, charges are identical, and then we need to divide by the distance between them, right? What is R? Look at this triangle, this point, that point. You see this triangle. And the whole R is this. But now first let's find this distance. This R, that's what we need. But first let's find this distance. L is given, this hypotenuse, and we need to find the side which is opposite to the angle. So this side will be L times sine of theta. This is L times sine of theta. So, but this picture is symmetrical, right, relative to this line. So this distance and that distance are exactly the same. So this is also L sine theta. So R will be equal, okay, let me move it slightly to the left. R equals 2L sine theta, because L sine theta plus L sine theta, it's symmetry. So it will be 2L sine theta, right? Okay, so now you grab this F electric and plug it here. And you have 2 equations with 2 unknowns. So you'll have, after this, you have 2 equations plus 2 unknowns. Which are those unknowns? Tension and this charge Q. 2 equations, 2 unknowns. Okay, now it's just the algebra. All right. Basically, we discussed physics. Now it's just the algebra of system of 2 equations with 2 unknowns. I will send you, my solutions, right, of the rest, right. But basically, we discussed the physics, right. And some explanations about the similar problem will be in your homework. Identical situation, but you will have to find angle. Okay, I will write you in the explanations in the email, because that problem there is a small trick which you must be aware of, right, about Taylor expansions. Okay, I don't want to hold you any longer because we're already like 4 minutes over time. Right. Okay, guys. All right. So if you have quick questions, ask me now. Right. Because you have to go to other classes. I also have another class in 6 minutes and 5 minutes. Right. But the rest of the solution, because now it's just algebra.